Okay, what do you need? San Diego, what? 15? Yeah, I didn't go down and see my son. I haven't seen him down in San Diego since he moved there. What are we doing? Just antiderivative of it? Okay. So antiderivative of 1 is x, but it's lowercase alpha, so that's what we're going with. Plus, what's the antiderivative of tangent squared? Yeah, what function has the derivative tangent squared? So look on your note card. Yeah, secant. Look on your note card, and you know the derivatives, so just go backwards. So that there's none that have tangent squared? Oh my gosh, so what are we going to do? All right, so what we're going to do is we are going to go to our old friend sine squared plus cosine squared equals 1. Okay, and we're going to change that into tangent squared somehow. So tangent is what over what? Sine over cosine. So I'm going to divide everything by cosine squared, like that. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So little simple algebra gets us to tangent squared equaling secant squared minus 1. Okay, so I am going to rewrite the integral as the integral of 1 plus secant squared alpha minus 1 d alpha. Okay, because I just replaced the tangent squared with the secant squared minus 1. Okay. What happens to the 1s? Cancel. Okay, does anyone have the derivative equal to secant squared? Oh, so that means our answer is tangent alpha plus c. Okay. Yeah, you can do tangent of x or y or z or a or whatever you want. That's fine. As a teacher, I'm supposed to do the right thing, so I'm doing that. Yeah. No, that's fine. That never bothers me. You will notice that sometimes I get lazy and don't even include the variable at all when we're doing scratch work. Yeah. 31. Everybody okay with 15? Okay, that's a little tricky one. We had to use a little trig identity to simplify that. So yeah, 31. Yeah, the alpha thing looks like fish. And then we have a symbol in statistics that's that, which is the capital or lowercase sigma. You guys know sigma because we just did that, but this is the lowercase one, and we call that the Angry Birds symbol because it kind of looks like the big red angry bird in the angry. Yeah, no. All right, 31. So square root of 5 over x. So I feel like we could rewrite this as the square root of 5 times x to the negative 1/2. What do you think about that, Brooke?
I was doing number 30.
Oh.
Like, can I rewrite the problem?
Yeah, I don't know.
Then I'll tell you what I think. Yeah,
okay. So do you need my help right now?
I don't know. I did the wrong problem.
Okay. Oh, because we were just doing the odd ones. Gotcha. You need 41. Okay. You said yesterday, why are you even assigning this? Nobody's going to do it. And I said, Elizabeth, Here she is asking on the last problem on the assignment, proving that she at least. You did or you didn't? Oh, okay. Good job. Okay, 41. Ah, yes, our old friend, the absolute value of x. Okay, so negative 1 to 2 of x minus 2 absolute value of x to x. All right, we have to change this into a piecewise function, Elizabeth. And the way we're going to do it is we're going to look at the graph of negative absolute value of 2x. What does that look like? Yeah, but what about the 2?
We're on 41.
Uh-huh. What about the 2? Nope. Yes, stretch of 2. Okay? So this is the graph of 2 absolute value of x. So what does this look like? I texted something funny to my friend during class. No, not at all. What is this equation right here? What is this one right here? Oh, don't make it worse. What? Negative 2x. Okay. What is this equation right here? 2x. So we can then break this down into 2 separate pieces. Where is the yeah, for sure. I'm going to end up on my rear end here pretty soon. But it's worth it. Doing it for Caleb and Mackenzie. Yeah. Oh, great. Thanks. That was really, yeah, worth it. So where does this change from negative 2x to positive 2x? At 0. So I'm going to rewrite this as 2 separate integrals. One is from negative 1 to 0 of x. It's minus 2 times the absolute value of x. So it's going to be minus negative 2x, like that. Does that make sense? Because it's minus this thing. Okay? And then plus the integral from 0 to 2 of x minus this piece right here, which is 2x. Okay? So I have to do those as 2 separate pieces. Yeah, from 0 to 2. So then this is going to simplify to be x minus negative 2x is 3x. So that's the integral from negative 1 to 0 of 3x dx plus the integral from 0 to 2 of this simplifies to be negative x dx. So antiderivative of 3x is
3 over 2x
So
squared.
I'm going to go 3 over 2x squared from negative 1 to 0. And then the antiderivative of negative x is? What is it? Negative 1/2 x squared? Oh, yeah. Okay. I wasn't expecting a fraction in there. Okay, so this time you have to go top to bottom. So if I plug in 0, I get 0. If I plug in negative 1 squared is 1, and then that's going to give me 3/2, but it's 0 minus 3/2. Okay, momentito por favor. And then if I do this one, plug in the 2 first, 2 squared is 4. 4 times negative 1/2 is negative 2. And then I plug in 0 and I get 0. And then I add those together and that gives me negative 3.5. Yeah. No. Yes. No. Yes.
But when you say your knees touch the desk?
I don't think so. No.
That's not very tall.
That would seem like that would be uncomfortable.
Why? But it was like this, like on me.
Yeah, no, I like to have the chair all the way up.
How do you sit?
I put my rear end on the seat.
Yeah, but
and I
I'm
put
saying
my
like
feet
because
forward.
you have tall legs, they're gonna stick up even farther than mine.
Brooke, I apologize for calling on Logan before answering your question. I don't know why I was thinking why I would ever do that. Okay, I'll try and learn from my mistakes. Okay, 35. So we have to do some trig translations here again. Okay. So I'm going to take this and break it apart into 2 separate fractions. All right. So 1 over cosine squared is 1 over cosine squared is what? I could also write that as what's 1 over cosine? Secant. Secant and cosine are inverses. So I can rewrite this as 0 to pi over 4 of secant squared plus, and then cosine squared over cosine squared is 1. Okay. Okay, then the antiderivative of secant squared is, we did this already, right? Yeah, it's tangent. And the antiderivative of 1 is x. And we're going from 0 to pi over 4. So if you plug in pi over 4, tangent of pi over 4, everybody knows, since it's a 45, 45, 90, and its opposite over adjacent, that's just going to work out to be 1. Plus, plug in pi over 4 for theta, minus, if I plug in 0 for tangent, then I get 0, and if I plug in 0 for theta, then I also get 0, so my answer is just 1 plus pi over 4. Okay? Good? Good?
Do 5 pi over 4?
No, because this doesn't have a pi in it.
Oh, okay.
You could do 4 plus pi over 4, but yeah.
It just seems funky to me. Okay.
Yeah, it is funky. All right?
I think I have it grasped.
Okay. Okay, so not much left in this section. We're just going to do some applications. So yeah, part 2 of the fundamental theorem says that if f is continuous on a and b, then the integral from a to b of f of x dx is equal to the antiderivative of b minus the antiderivative of a. We know that the derivative represents the rate of change, right? Talked about derivatives as rates of change and all that. You're kind of going sad face on me. Okay, so we can reformulate the fundamental theorem of calculus part 2 in words as follows. We could call it the net change theorem. So you could say the integral of a rate of change is the net change.
Stop looking at me like that.
Okay, stop looking at me like that, and I'll stop looking at you like that. Okay, good. I'll look at the screen too. So here are some exciting examples from the world around us that we could use this to solve. If V is the volume of water in a reservoir at time t, then its derivative is the rate of change at which the water flows into the reservoir. So that means the integral of the derivative is the change of the amount of water in the reservoir between time t1 and time 2. So derivative, how fast is the water flowing out? Integral, opposite of that, how much water has been added to the reservoir. Okay? If C of t is the concentration of the product of a chemical reaction at time t, then the rate of reaction is the derivative. So the integral is the change in the concentration. Yeah. Okay. Colby's like, not even, yeah, okay. If the mass of a rod measured from the left end to a point x is m of x, then the linear density is the derivative of that. We talked about that before. So that means the integral is the opposite of that. It's the mass of the rod that would lie in between points A and B. Okay? And so same thing with population growth. The derivative is the rate of change in the population. The antiderivative is the amount of population change that's actually occurred, and so forth. Okay? The fun one, though, is acceleration and velocity and displacement, because those are very common and very useful. And so as I mentioned at the end of class yesterday, we know that if you start with displacement, the derivative of that is skipped one, is velocity, and the derivative of velocity is acceleration. Well, now we know integrals, which are just antiderivatives. So if we start with the acceleration, we can take the antiderivative and get the velocity, and then we could take the antiderivative of the velocity and get the displacement. So if we have position, and then we have velocity, and then we have acceleration, then when we're going this way, that's derivatives, and when we're going this way, that's integrals. Okay? Noteworthy. Secret word of the day, Hawaii. Week? No. No. No time for humor in a serious class like this. Humor? Well, that must be why you hate this class so much. McGuire said all you do is complain about calculus and how much you hate it. All right, so if we know that, am I blocking you, Brooke? If I'm, okay. So if we know that velocity is t squared minus t minus 6, then how would we find the displacement of the particle between the time period 1 and 4? Antiderivative, right. So that means I'm going to take the integral from 1 to 4 of t squared minus t minus 6 dt. That make sense? I'm going the other way, going up instead of down. So antiderivative of t squared is 1/3 t cubed, I guess, minus the antiderivative of t is 1/2 t squared. And the antiderivative of negative 6 is negative 6t. And we are trying to go from 1 to 4. Okay, so, it's recorded for all eternity. Okay, so now you just plug in 4. So 4 cubed is 64, right? So that's going to be, what's 64 divided by 3? 21 and a third? Yeah, okay. Minus, if I plug 4 in there, 4t, 4 squared is 16, and half of 16, that one's a little bit easier, is 8. And then if I plug in 4 there, I get 24. Minus what I get from plugging 1 in, which is going to be 1/3 minus 1/2 minus 6. So what's all of this stuff come out to be? Negative 10 and 2/3, because there's the 2 and the 2/3 plus another 8 is negative 10 and 2/3. Sometimes you go too fast, so I'll have to check in my own brain to make sure that it works. No, I trust you. I'm not saying you're stupid. Okay, then I have to get a common denominator between the 1/3 and the 1/2, which is what? 2/6 here and 3/6 there. So 2/6 minus 3/6 is negative 1/6 minus 6 is negative 6 and 1/6. Right? Because they're both negative, so okay, but then these two negatives become a plus. Then I need a common denominator there, so that's going to be negative 10 and 4/6 plus 6 and 1/6. That's a negative. Negative 4.5? Okay. Okay, so it's displacement between the time there is negative 4.5. Okay? Feeling good about that? Okay, find the distance traveled during this time period. So now we need to go back to the original velocity equation and find out when between the time interval of 1 and 4 did the velocity stop. When was the velocity 0? So I need to take t squared minus t minus 6, set it equal to 0. So negative 3 plus 2. So t equals 3 and negative 2. Nobody cares about negative 2 because negative times and blah, 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 right? So that means from 1 to 3, it was going one direction. And then from 3 to 4, it was going the other direction. Okay? So you need to find out what those two individual things are and then add them together. The good news is we already have the antiderivative of this because we did it for the last problem, so we don't have to redo that whole part. So we know 1/3 t cubed minus 1/2 t squared minus 6t, and that's from 1 to 3. And then same thing here, 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 3. Or not from 1 to 3, sorry, from 3 to 4. Okay? So if I plug 3 into here, then I get 27 times negative 1/3 is negative 9. Was it not negative 1/3? Was I? Oh. Oh, no, you're right. It's positive 1/3. Okay, sorry. Is it? No, because it's negative t, so those are going. These two are going to be negative, but you're right. The front one is positive. Okay, so that's going to be 9. And then if I plug 3 into here, 3 squared is 9. Half of 9 is 4.5, so that's minus 4.5. Then plug 3 in there, that's minus 18. Okay, minus what I get when you plug 1 in there, but we already know what we get when we plug 1 into there because we did it right here, and we got negative 6 and 1/6, right? Okay, so that's going to be minus negative 6 and 1/6. Well, so let's see. I don't know, who made these numbers? Negative 13.5, right here on top, okay? So negative 13.5, I'm going to rewrite as negative 13 3/6 plus 6 1/6 equals negative 7 2/6, which is negative 7 1/3. Okay. So then for this other one here, so that means in the time between 1 second and 3 seconds, it went negative 7 1/3 units to the left. Does that make sense? Okay. Then between 3 and 4, if I plug 4 into there, again, we know that from this previous problem here. When we plugged in 4, we got negative 10 2/3. Is that true? Where do these come? What are those from then? Oh, because I got a common denominator. Okay, thanks. So that's negative 10 2/3 right there. Minus, we plugged 3 into there already and got, whoops. Right, okay, good. So plus 13.5. So that's negative 10 4/6 plus 13 3/6 is, I don't know. You have to borrow or something, don't you? 1 5/6, maybe? If you add 1 5/6 to 10 4/6, do you get 13 3/6? No? 2 and... My brain hurts. It is 2. I'm going to go with 2 and 5/6. 2 and 5/6. 2 and 5/6? Okay. So it went 7 1/3 to the left, and then 2 and 5/6 to the right. Okay. It says what? It says what?
I don't even know what I'm looking at right now.
Oh, okay. But we want to find the total distance that it traveled, so we're going to make these positive and add them together. So 7 1/3 plus 2 and 5/6 is really 7 2/6 plus 2 and 5/6, I mean. So that's 9 7/6 or 10 1/6. What'd they get? Yes. Drop the mic.
No, you're gonna break it.
It won't break. It's making a lot of noise right now, I'm sure, if Caleb or Mackenzie is actually... Yeah, sorry guys. Okay, so what is true about these two answers and this answer? sort of. If I go negative 7 1/3, I mean, if I go 2 5/6 minus 7 1/3, then I'm going to get negative 4.5, okay? Because this is the overall displacement. But this is it broken down into two separate distances, and then you make them both positive and add them together, okay? Okay, yeah, don't want to do that. So the way you would do this is you would make rectangles and add them together. And that always seems dumb to me because you're just like estimating heights, and that's, I don't know, not so cool, okay? All right, so you want to do some problems with velocity? Yeah. Oh, Logan does? Oh, wow. Let the record show, Caleb and Mackenzie, that Logan is nodding his head enthusiastically, saying, yes, I really want to do some
I was shaking my head.
lies. Okay,